Hey everyone, Renato Lit here, and today I was invited to join and participate on the Dynamics Coolest Demos Challenge, and I thought, wow, that'd be fun. And if you haven't seen any of our videos, the Dynamics Coolest Demos Challenge is pretty much a very cool and fun way to solve real problems using Dynamics, Azure, Microsoft technologies in general, and a lot of creativity and innovation. And the challenge that I got for this week, actually I got two challenges, which are how to detect sudden variations from readings from IoT sensors, and with that generate alerts for connected field service and automate the work order generation process from the IoT alert until it gets to the partner with partner's work order distribution. This is a very awesome challenge, because if you're used to the Dynamics connected field service sample that you've probably seen in many different videos, it relies on IoT temperature, and you have a simulation page, and you can of course use IoT Central or IoT Hub, but the thing is, usually there's a threshold for the temperature, and when the temperature goes above that threshold, that will generate the IoT alert. The problem is in many real case scenarios, just by reaching a threshold is not enough to be considered alert. Let's say that you're monitoring the temperature along a pipeline. During the day, the temperature will vary a lot. It will go up, and during the night it will go down. And the simple factor that it's going up, it's not necessarily a problem. The problem is if it hits too much suddenly. Let's say the pipeline cracked and then went into flames, so it's really hot there. Or if for some reason the temperature goes really down and it's really cold, and that might freeze the pipeline and crack it. So you want to only generate alerts to this sudden variation, but not necessarily to a specific threshold. And the same can go to pressure. Let's say you're monitoring the pressure inside the pipeline. If the pressure increases or decreases a little bit, or in a steady way, that's totally fine. But if it the pipeline cracks and the pressure goes down real quick, then you have a problem. So for that scenario, I was thinking, oh, how can I achieve that? So what I did is I found this awesome reference architecture and article from for Azure that allow us to detect anomalies in real time by using stream analytics connected to some machine learning, and then push this information to either Power BI and a queue. So it's inside Azure. We can pretty much do whatever we want there. So this is pretty much what we're looking for, because we want to detect anomalies and not something that's going below or above a threshold. So how did I implement that? So I started on Azure, of course, with a Azure Stream Analytics connect to my IoT Hub. And what I'm doing here is pretty much leveraging the anomaly detection capability, and you can get all that from the documentation, where I'm monitoring for spikes and dips within a time window and a threshold, a certainty threshold, a confidence level. And if it goes, if it spikes or if it dips during this time, I'll be able to catch that. And then as output, I'm sending this to my alert queue to push this to a connected field service, and also to Power BI, so I can pretty much see what's going on. Everything else is the default implementation for connected field service. So from this queue, this all this component, Azure component will be installed for you. From that kill, this logic app will catch the spike or the dip, will process and send it over to Dynamics. So I have a bunch of entries here, and that already happened. So if I pull my Power BI here for a second, so I'm getting here, I'm measuring 3 things here in real time. So I'm checking the device temperature. So here in my house is around 27 Celsius degrees. And I can see here that I'm monitoring this gyroscope X. And the reason I'm using gyroscope X is because I want something that varies a lot, so it's easy for me to track these anomalies. And here we already have a very awesome and good example here. So you see that although the gyroscope is varying a lot, it's varying within a range. So only when, and it just happened, it varies more than this range, it caused a spike or a dip that will generate an anomaly that will be perceived by Azure and sent to Dynamics. And from how I'm producing these anomalies and this variation, well, I'm pretty much connecting my MX chip here that is connected to my Wi-Fi and send real-time data to Azure. And as I move it, I can see my hand. If I play with it, I can change the information and cause all this variation that will ultimately generate the anomaly. And cool. So I said that everything that's happening here, it's just triggering, catching the anomaly, and everything else is connected field service all the way. So if I go back to Azure, that spike will go from Azure Stream Analytics to the kill, and the kill is being monitored by this logic app, and the logic app will pretty much collect data from the kill, get this IoT message, and create a new record inside Dynamics. That's pretty much what's doing. So let's jump into Dynamics for a second. So if I go here to my connected field service, I have like 19 alerts from all my tests. So I'll just refresh and I'll see the new one. So I have 20 now, and it's right here, the reading from the gyroscope. So if I open the gyroscope X reading, I can see that's coming from the MX chip. I can see all the information in real time from that Power BI. I know it's anomaly detection that triggered that. It's not a threshold specifically. I know what's the reading, the confidence level for a spike and dip, and if it is a spike and dip. So this is the JSON control, really awesome control for connected with service. So I know what's going on here. But this is just the first part of the challenge. The second part is being able to automate the process from the IoT Alert. So from here, we go to flow, and we can see that there's a running flow here. And this running flow pretty much saying that from that IoT Alert entity creation, record creation, it's collecting some data and send this for approval. So let's say I'm a manager on the go. I don't even have to be connected to Dynamics. I'll just receive an email saying that, look, we got an anomaly that was detected. I need you to take some action, and I can approve or reject. So from within my email, I can do everything that I need. So I can put some notes and track that down later. So let's say I approve. So I'll submit that. And yeah, I want to create this to a partner. So if I go back to my flow, you're going to see that everything else happened here. It got the approval. It created a new record. So pretty much everything that I wanted happened here. So if I go back to Dynamics and go to our work orders, I'm going to see that work orders were created for Contoso partners here, 19. So from now on, I want my partner to act. So for a partner to interact, the best way to go is to leverage Portal. So let me switch hats real quick here. So now I'm logged into Dynamics Portal as Nance Anderson. She's a partner from Contoso Partners. And if she goes here to the field service, she can track down all the work orders that are assigned to this part. So I have to support my customer, but I use partners for that. If I see here, I have a very cool map that I can just click and go down and focus on one specific state. If I just hover mouse, I can see where each work order is located. If I go down here, I can see the details of that work order. So this one that was just created is in Miami. Here, number 19, the same one. If I click on that work order, I can see the details. And as a partner, I can accept and go there and support my customer, or simply reject. If I go back here, and if you're wondering where did this map came from, so it's very easy to integrate and to extend and customize the Dynamics Portal. And the way, because you can add JavaScript to it, what I did here is pretty much use D3 visualizations to get this data here, the work orders that are assigned to this partner, and plot in a US map on the specific longitude and latitude for that. And of course I add some animation here so you can zoom in and out to the states by just clicking. But the way I did that to get this information here, it's the best way to do is to get a JSON version of this information. So for that, I created here, so let me refresh to get the latest work order. I created a very simple script that will run a query inside Dynamics and bring the work orders that are assigned to this partner. If we go to the portal configuration, you can see that's really simple. It fits all in this one page here. It's a fetch to get the fields that I need under certain conditions. So those that are for partner approval, and I am the partner. I'm logging as Nancy, and we'll bring and then loop through the records and generate the JSON file. So it pretty much generates this JSON on demand and present to the portal. So with that, we pretty much cover the scope of this challenge successfully. And as a recap, from our IoT sensor, we use the anomaly detection in real-time data streams from Azure to get the information from the MX chip in real time, present this to Power BI, at the same time run the anomaly detection and use that information. If anomaly is detected, we send this to a queue, an Azure queue, that is then caught by the logic app that will create the work order, sorry, the IoT alert inside Dynamics. And inside Dynamics, I use Flow to send that IoT alert for a further approval from the manager within his email. And once it's approved, it sends back to Dynamics as a work order assigned to a specific partner, and that is displayed in this cool map using D3 visualizations with animations and so on. And with that, I completed successfully my coolest Dynamics challenge. Hope to see you next time. Take care.